Hi, everyone. I'd like to thank you for joining us today for our webinar, Automating with Linked Clones, How to Improve Build Times in Your Mac VMware Cloud. I'm here with Max Kelley, Manager of Systems Engineering here at MacStadium, who will be leading the webinar today. Just as a reminder, you will be muted for the duration of this webinar. If you have any questions for Max, please put them in the chat or questions pane, and we will get to them at the end of the webinar. We will do our best to answer all questions, but if we run out of time, we will get back to you after the webinar. Now, without further ado, I'm going to hand things over to Max.
Hi there. Thank you all for joining. As stated, we're going to be covering how to automate linked clones to improve build times in your MacStadium VMware Cloud environment. Just looking at what we have here today for our agenda. The who, what, why, and how. A lot of customers are still out there using traditional methods of VM creation, typically taking a Mac OS image or template and cloning out from that as a full standalone server, and are unaware that VMware has a lot of automation or tools that you can use to improve that process, and one of which we're going to be covering today is linked clones. We intend this to kind of help developers and admins get a start on the linked clone process to automate their builds and their infrastructures. A lot of people might not be aware it's out there because it is not in the web UI, and typically you are having to make API calls or through automation tools to make those things happen. So we're going to be looking at what the basic structure to get that accomplished looks like, and the bare minimum configuration to getting a linked clone deployment set up in your VMware environment. If you're already using tools like Ansible and Terraform and they're part of your workflow pipeline, this might be kind of the same material that you've already gone through. This is more intended for people that haven't really been exposed to Ansible or just curious about how to improve and develop that process a little bit better. But going in, you will need to kind of have a little bit of basic knowledge of the VMware infrastructure, as well as some experience with the CI/CD tools. But we'll be covering what those basics are to get that accomplished look like. So the agenda here looks like this. We're going to be covering the different cloning processes. Then we're going to cover what the linked clone structure and process looks like. We're going to talk about the considerations for implementing in a CI/CD type environment. And we're going to cover using local SSDs as a part of that as well to improve some performance there. Then finally, we're going to get into the actual technical details around how to get started, and we'll do a demo of the Ansible and Terraform tools to do that. So the different types of VMware cloning, standard clones, linked clones, and instant clones. Standard clones is the old traditional method. It's been a long time industry standard. What we're doing is basically saying I have a VM out there and I want you to clone all the properties of this VM, and I need you to make that completely independent from my existing VM. So there's no relationship to the parent at all. We are completely cloning everything, every block on the storage level, all the configurations, and you can modify some of those after it's deployed and configured, but there's not going to be anything tying it back to the original source VM. Linked clones, on the other hand, uses a single parent VM for the read I/O and puts all the write I/O onto separate disks. And because of that, there is a dependency on a parent VM. We're going to be talking about parent VMs, cloning, and templates kind of interchangeably. Just know that the different types of tools that are out there might have different standards and requirements for that. But we're just going to be using the term template kind of interchangeably for what that base image is going to look like. And so because we are going to be referencing the single parent VM, there is no need to copy the contents of the base disk. So whereas the traditional method is we are going to read every block and then copy that block over, in this case, we only have to read those blocks. We don't need to create an additional copy of those blocks. The linked clones have been around for a while in the VMware space. They are heavily utilized in a VMware Horizon VDI environment. That's a virtual desktop infrastructure. If you've not used any of that, I know with the Corona stuff, that's become kind of a popular tool to be used. So most of the pools and creations have used the linked clones for a while in there. And because of how long it's been around and how mature the product is, a lot of the automation tools have adopted that technology and already have that fairly integrated into their systems. VMware does have a new type of cloning process out there called instant clones. It's still a fairly new technology, and so because of that, it hasn't been as widely adopted inside of automation tools. That'll probably continue as it goes on. And then the process of creating the VM is a bit different in that you're using a live running VM, and then you stun it to be able to replicate out the other systems. So we're not going to be covering instant clones today. We're going to stay focused on the linked clones here. So when we talk about a standard clone, we are looking at the VM itself and the VM disk. We can see here we have 4 different examples of what that kind of can look like. Doesn't really change much based upon the scale and what you're doing. You can see that regardless of host count and data store count, all we're doing is looking at the VM properties and the VM disk itself, and then we are cloning that to another system with those same kind of specs and information. But the linked clone process is a bit different. We're going to talk about the structure for a linked clone. So linked clones, typically, to create a linked clone, you need to have a parent VM, and on that parent VM, you need a snapshot, which is basically a point-in-time reference of that VM and its current state. And most of the time, that snapshot is going to need to be taken while the VM is in the powered off state. What that does is it puts the OS, in a idle, like non-functional state, and allows the VMs, when they are created from that parent VM, to go through the entire boot process and go all the way up. The host that is running the linked clone VM, as in the one that we're going to be cloning to, that host needs to be able to access the parent VM's disks. And what that translates into is that your parent VM should be on some type of shared storage that can be accessed by the ESX hosts in your environment to be able to run that system. Now, the linked clone itself can run on any other data stores that are available to it, as long as your primary or your ESX host can still reference back to that parent VM. So the real gotcha there is you don't want to be running your parent VM on any local storage that can only be seen by a single host. Otherwise, you're going to run into issues trying to create your linked clones. In the structure, we talked about the read operations happen from the parent VM, the template that we're going to be using, but the writes go to a separate disk. And inside of VMware, when we create a linked clone, it automatically goes out and creates 2 different types of writable disks. One is for the temporary data, that would be like machine passwords and any unique identifiers about that system. And the other is where all is stored for temporary data, that would be the actual write operations that are going against that VM. And then that way there's a separation between your write and read operations in the system. And you can see it can be on any available storage, including the local SSD. Multiple linked clones can be created from a single parent VM and can run on multiple hosts as well. So this is a one-to-many type of relationship where you can have a single parent VM of, let's say, a Catalina OS system, and I can spin up dozens upon dozens of VMs from that one image on multiple different data stores and multiple different hosts. The limits from VMware go up into the thousands for that, but obviously your mileage may vary as we get into that. And then the linked clone VM itself will show a reference to the parent VM data store. So if you are deploying a linked clone on a separate data store, you might see something stand out where it shows a data store that was not originally associated with your linked clone. And what that is it's actually referencing the read-only disk. Where to see all that's kind of hidden in there, and so we're going to see that in the examples here in a little bit. And so we're going to look at the process here, kind of visualize what's happening, and we can see on a one host, one data store, we can have a local or shared data store in this environment. And here we have our template VM. The VM itself is powered off and would actually be a template in this case. The VM has a disk on there, and then we have our snapshot from the VM in that powered off state. And so when we clone out that VM, we're going to see that we have our linked clone VM. And we have 3 different disks here. We have a linked clone temp disk, so this is where that machine password type of information will be written to. We have a read-only disk, and then we can see this line associating this back to the snapshot. And so all the read operations are hitting this disk, but we're not actually, this disk isn't actually on the system. It is still associated with our template. So we are just referencing back to that snapshot for that system. And then finally, all our write operations are going to this linked clone Delta disk. We can see if we go over here to one host and 2 data stores, that process is also similar, local or shared data store for either of those, because we are only using a single host, and that host has access to both of those data stores. Well, if we go look a little further, we're going to see things a little different. 2 hosts, 1 data store. In this case, it would have to be a shared data store for this environment for the parent VM to be accessible by the other ESX host. So we could not use local data stores in this type of instance. And then finally, we get to 2 hosts and 2 data stores. The original parent template VM lives on this ESX host, and we keep that on the shared data store. And we need to be sure that the other ESX host that's out there has access to that shared data store. And then it can deploy linked clones on any type of storage underneath it, as long as it can still make that connection back to the original parent VM. All right, so considerations for CI/CD. One of the first things to really think about if you're just getting started in the automation space and looking at these tools is you need to choose the right automation tool by understanding your build structure. One of the big key factors in that is if you plan on doing ephemeral type builds or stateful builds. And what I mean by that is if you plan on having a ton of VMs that spin up and spin back down, they just have to serve a single purpose, run the task, and then I don't need anything left from that system, well, then that's typically going to be an ephemeral type of build. But if you need to spin up web servers and you need these guys to stay around for a while, or to have some kind of length to those systems, and you just keep updating those environments with that, then you're looking more at a stateful type of build. And the 2 different automation tools we're going to be talking about today kind of address both of those aspects. Ansible is a bit more in the ephemeral space, and Terraform is going to be more of a stateful type of approach to that. And so you just really need to ask yourself what you're trying to accomplish before you start going down this road, just to make sure you don't choose the wrong tool when looking at this. Another thing that really helps is having a DHCP scope for simplified network management. In the MacStadium environment, we typically provide a private network for the customers to run their VMs in. You would want to set up some kind of DHCP server out there to hand out some of the addresses in that space, just so you don't have to worry about static IP addressing in the systems. You can still do it via static IP, but there are some gotchas around how you need to handle that in that instance. Setting up your SSH keys on your parent VM and deciding on your strict key policy. So you'll probably want to check with your security teams to understand if there are any rules around how your SSH is configured or just any security access to systems. But typically, just by installing your SSH keys from your deployment server onto your template VM, that means any VMs that you spin up, any linked clones, will automatically have those keys already on there, and that speeds up your access for being able to continue to push different commands to that. Strict key policy, if you're looking at if you have that enabled, then you'll still get prompted anytime you deploy to say, hey, is this key valid, because I didn't verify that. So if you're allowed to, you should try and disable the strict key policy in your environment to make the process as smooth as possible. Consider using snapshots on your linked clone after deployment. So let's say I have a parent VM, a golden image out there, and on that image I want to deploy the linked clone, and then afterwards run commands. And when I'm done with that, I want to be able to go back to that original state on the system that was the golden image before I ran any of those commands. Now, you have the option of going out there to just delete those VMs and redeploy them, but depending on how much management and other stuff you needed to do, that could add a lot of additional steps. Another option would be to go out and once you have deployed your linked clone, you can take another snapshot on that same linked clone. And so now you have a good point and reference time that all you need to do is say revert to snapshot to restore it back, and you don't have to go through that process of reconfiguring all the different little tools or agents that might need to be set up on the system environment, or if you are doing static IPing, you don't have to go back and redo that on that system. Another thing is that your parent VMs should be kept up to date and to make sure you take new snapshots. So when you're going to be, let's say Mac OS has released a new version or patch update for the operating system. The easiest way to get everything up to date would be to take your parent VM, power it back on as a normal VM, go through the update process there on it, and then power it back down and take a new snapshot. Depending on your tool, you might have to remove the existing snapshots, or you'll just need to know the snapshot name on the VM when you do that. Another option that you could look into is using template building tools like Packer to manage those parent VMs. So in this case, we're talking about a parent VM that we managed and built up and got exactly where we wanted. But there are other automation tools out there that allow you to say, take a ISO image, run through the entire OS install, and then run different types of commands at the OS layer, and then make that the template. And then that way you, again, have taken away the manual process of needing to manage and maintain your images, and instead you have pushed that, again, towards the automation. So you have another step of the puzzle that's automated for your environment. Determining how to handle system records for tools like antivirus and host names. One of the common things we've seen with customers doing any linked clones or replication builds is that you'll typically get a response or a pop-up message on your image that says, hey, I've seen that there is Mac Pro 1 already out there on the network. So there's a conflict here because I'm named Mac Pro 1. And so it's just a minor pop-up, not a big deal, but depending on what your workload and what you're doing, that might cause problems. Or if you're using different antiviruses, you might get duplicate reports or a list of 40 systems that all say Mac Pro 1 in the environment, which would obviously disrupt a little bit of your workflow. So just determining what your needs are and look into that for changing out the system for your builds. Make sure your parent VM is locked down to prevent unwanted security issues. So depending on what type of CI/CD you're doing, if you have multi-tenancy, different types of customers that are going to be coming in there, you'll need to make sure that the parent VM itself is secure and locked down. Any linked clones that are built off that are going to have the exact same security policies. So if you want to make sure that no other VM can see another one, then you'll need to make sure you've locked it down at the OS layer, or look into different firewall type tools that will make that process easier. And then finally, identifying linked clones can be difficult. Inside the VMware space, there is not a nice little checkbox or property fields out there. There are some things that you can call via the API to determine that, but it can be a little difficult trying to track that down. So one thing you consider is adding tags to the VMs that they're built up that just indicates that this is a linked clone VM. Yes or no on that process to look at that. So a lot of this, we're going to be deploying the VMs out onto the ESX host, and we have data stores that are attached to each of our hosts for us to be able to do that. But we have also seen an increase in customers looking to try and speed up performance and improve that process. And so one of the things that we've seen a lot of people do is starting to utilize a local SSD drive inside of their ESX host to do that. And what this does is when you make the call to say, I have my parent VM and I need to clone out that VM onto another host, your ESX host is going to make the calls to the data store through on the array and say, hey, I need you to clone this guy out and make these new disks on this system. And so it's going to make the read-only reference and put all that there, and then any writes are still going to be written to that array. So if you're doing, say, 40 VMs at one time, well, now your array is pretty taxed because it has 40 different disks that it's trying to create, and 40 different calls and references that are constantly going on to that same parent VM. And so instead, what we can do is, if there is a local drive inside of the Mac Pro system, we could say, I want you to create me a linked clone, but I want you to make it on the local disk that is available in that ESXi host. And when we do that, we are saying, okay, I want you to give me the read operations from the parent VM on the array, but then in the ESX host, it says, I need to make the write commands through a different bus, through the local bus in there, and I'm going to process all my write commands on this local SSD. And so now your array has freed up a little bit of the I/O and can perform a little better and keep up with the commands, and the ESX host is, and the local SSD is doing a little bit more of the heavy lifting. Using the local SSDs, though, is typically going to require a few different additional configuration steps in the automation tools, and that varies by the tools. We're going to be looking at some examples here of how that varies between Ansible and Terraform in just a few. A few things to note about using local SSDs, though, is that HA and failover are not available if a linked clone is running on SSD. HA is high availability, which basically says if I have a host failure, I want you to move any running VMs on this system over to another host in this cluster, and then I want you to power it back on. Well, if the linked clone is on a local SSD, then the other host won't be able to reference that system. So that failover process is going to fail because that VM is specifically siloed to that ESX host. And similarly, host vMotions and DRS are not really available for a linked clone. Now, you can have DRS and HA still enabled in your environment while this is running. Just know that some of the functionality might not work as you expect them to based upon this. So host vMotion is the process of moving your VM from one host to another using the different compute resources. But again, because the storage is not the same on both sides, you won't be able to make that move. Now, you could do a host and storage vMotion and move the entire system, but then you're actually having, again, to do a bit of the file copy across the two different hosts, and so that can slow down that process there. If you are going to use local SSDs, then one trick is to name your local SSDs using the ESX host IP for easy referencing. And the reason for that is that when you are running local SSDs, you're going to have multiple different data stores out there, right? So one for each different host in your environment. So how do we associate that local data store to that particular ESX host? And the easiest way is just to use some reference from that host. In the MacStadium environment, when we add your hosts into your vCenter, we use direct IP information, and that's usually a very unique, standalone system. So by doing that, we can use the last octet of the IP range, and that gives us that same kind of association. And then I can quickly associate what host a VM is running on by just looking at what data store is associated with it. And then finally, local SSDs are not redundant. In the Mac Pro system, we are only able to install a single SSD drive in there. And so if you have a hardware failure, the SSD stops responding for any reason, or something's gone wrong with it, we will not be able to restore any of that data that's on there, and typically, it will just be replaced. So that noted, make sure you don't keep any crucial data on the local SSD. So it's typically more intended for the ephemeral type of systems, or at the very least, you need to be backing up to an external or some kind of external drive for maintaining that system if you have to restore it. All right, so how to get started. So we've gone quickly through a lot of the concepts and what's there. Let's talk about what we need to do to actually go out and test this system and actually build this. So in my lab environments that we're going to look at here in a second, this is the basic infrastructure here. I have a DHCP server on my private one network with a 10-minute lease time. I do 10 minutes because a lot of my stuff is built up and torn down very quickly. So I just want to make sure that I have a good flow and pool of IP addresses that I can use. If you don't plan on building a ton of systems all the time, you can probably go with a little bit of longer lease time. But if you do plan on CI/CDs and build-ups and teardowns, then you'll want a short lease window on there. My deployment server that I'm going to be doing all this from needs to be able to communicate with my vCenter. In your MacStadium environment, your ESXi and private one networks should work by default. They should, the ESXi network is the same network that your vCenter's on, so obviously communication should be good there. And then your private one already has the firewall rules to talk back to the ESXi network and the VCSA. If you plan on running this from a local system or not inside the MacStadium environment, then you'll need to have an additional step that puts you on the Cisco ASAV to be able to VPN in and talk to the environment before you run the commands. I have my VM template. It has the latest VMware tools installed. You should always have your VM tools updated for any new versions of ESX and things that you're deploying. And then I also have my SSH keys imported so I could run my commands after I've deployed the systems against those VMs. I have my single snapshot on the template as well while it was in the powered off state. So again, we got it in the good prep state now. If you plan on doing this with Catalina VMs, make sure you are at least running vSphere 6.7 Update 3. If you are already on 6.7 in the MacStadium environment, then we have documentation out there for how to get your stuff upgraded to Update 3. If you're running anything before 6.7, then we'll probably have to assist you with getting upgraded to that. And you can just open a MacStadium support ticket. We'll get out there with you. You can use your local administrator accounts to run these commands, but best practice would be to go on ahead and create a separate account for deploying these systems. And that's twofold. One hand, if you do have something wrong in your configuration or something like that, you could potentially lock out your administrator account, which would be, pretty difficult and cause some slowdown in your processes to be able to restore that. And then secondly, having an account allows you to start looking at metrics and build type of tools to understand how long it takes to run different commands based upon, the user ID that's used to execute those commands. And so you can easily go create any accounts you want inside of the single sign-on domain in the vSphere environment. You also might consider using customization specs or configuration tools for post-deployment processes. So what we were talking about for the IP addressing and any other types of minor configurations that you want to do on the back end after you've deployed your link clones, there are definitely some tools out there to set that up and again, tie into your automation pipeline. And then lastly, the local SSD named local data stores as local_SSD_MP, where the numbers are the last octet of my host IP. All right, so that's the bare bones, kind of basic, what my lab looks like to be able to do this. We're going to talk about Ansible next. And so this is the basic setup for Ansible. It's typically recommended to run on Mac OS or Linux server. You can use a Windows subsystem Linux if you really want to run Ansible on Windows. But in this case, in this instance, we're actually going to be using a Catalina OS VM to do all of the actual deployments. So that's going to be my management server here. I have Ansible 2.9.x, any latest version should work. Python, we have version 2.7 and up. Any of those should work pretty standard across the board there. We typically will need to add additional components in order to do the VMware commands. Those two additional components are requests and PyVMami. So we use pip to install both of those different subsystems. Finally, in Ansible, we need to have a few things specified in the environment, one of which is the snapshot name on the template. So when I took my snapshot on my template, I gave it a name in there, and I need to know what that name is so that I can reference it as part of my Ansible deployments. I've created two separate types of YAML files, one for building up my VMs and one for tearing them down. You don't have to use variable files to do this, but it is recommended because it'll definitely speed up the workflow and process, and I'll show you in our demo what that kind of looks like. And then finally, one last little gotcha there is that there are actually two different types of VMware interfaces inside of Ansible. vSphere Guest was the old one that has been deprecated and no longer used, and VMware Guest is the primary one. So just make sure you're using VMware Guest when you start going down this road and don't get confused and accidentally use the wrong one there. So we're going to back out of the slides real quick And we're going to go into my lab environment here. And so here we can see my Max VCSA Sandbox MacStadium lab. And I have a few different clusters here, a deploy 12-core and deploy 6-core for the different types of Mac Pros in there. If we go and look at this host, I can see that I have a Sandbox iSCSI storage, so that is my shared data store. And I also have my local SSD MP16. If we look at my lab host 15, we're going to see a similar thing. So my shared storage is available to both these systems, and I have a local SSD. And then same for my 6-core. Now I have my template. And if we come here to my cat bench template, we're going to turn this back into a virtual machine real quick. And we're going to see here that under snapshots, I have a single snapshot on the system, and the name of it is Bench and IC. So that's the main thing I need to know from this. And in this case, I need this to be a template instead of a regular VM. All right. So we have the structure there. And we can see here that the hardware count right now on the system is 8 CPUs, 64 gigs of RAM, and I have a 90 gig hard drive with the system on the private one network. So we're going to go here to my deployment server. This is a Catalina OS system, and all I've done in this system is install, you can see here, Microsoft Visual Code and the bare minimums that we were talking about for Ansible out there. And so we're going to look here at this Ansible build YAML, and we can see some of the basics up top here for Ansible. So we're going to use my local host, this deploy server, to manage the actual tasks. We're not going to do any fact gathering or make sure we're doing this in a sorted order. We're going to reference my variable file here, and we're going to go look at that here in just a second at what's going on there. And then we're getting into the actual tasks. And if you've never messed with Ansible, note that the spacing and indentions are very intentional. You'll get a lot of errors if you don't have the exact spacing for any of this stuff. So we named it something generic like create linked clones. And then under here, we have the task, the VMware guest that we talked about earlier. And if we see here under Visual Studio, we even get documentation to go and look at the different variables that we can set inside of this VMware guest. In this case, some of these are optional, and I'll cover which ones are kind of required here. So host name is the vCenter itself that we're going to be going to reference, and we have a username and password to be able to log into that. In a MacStadium environment, the certificates, we are not going to be validating them because everything's going to be self-signed, so we need to make sure we have that validate cert set to no for our vCenter environment. We can optionally set which folder that we want to deploy these VMs into. And then we definitely have to give it a name. So we have a template here where it's VM name based on my variable file underscore item. An item is based upon the sequence or count of VMs that I want deployed. So you can see here I can deploy multiple VMs from a single build file. And so it'll increment that number based upon the item, which is the count of VMs down here. Next, we need to know the template name that we're going to be referencing. And then we need to give some basics around the location of it. So we have the data center, which if you look over here, you can see Max Data Center is the name. Most people don't know this object exists, but we do need to reference that. The cluster I'm going to be deploying to, as well as the data store that I want this VM to run in. Next, we're going to say I want it to be powered on. So this means that as soon as it's built up, I expect you to power on that VM. Wait for IP address. So you can see here I have this commented out. If you plan on doing static IP addressing, then you will need this line. Otherwise, Ansible is going to wait for an IP address to show up on the system. And if, depending on how long that takes you to get in there and access that system, you might get a failure or some kind of false positive back from Ansible saying, I failed because I never got an IP address for this system. Since we're using DHCP, we don't need to worry about this property because we will get the IP address immediately once it's spun up. Next is linked clones. This is a flag to say yes or no, whether or not I want it to be a linked clone or a normal clone. And then if we are using linked clones, then we have to provide a snapshot source name. So this is that bench and IC we talked about earlier. And then finally, we can actually get into the hardware down here too, where we can say, well, I don't need it to be 64 gigs. I want it to be 32 gigs instead. And I don't need 8 vCPUs. I only need 2. So we can actually control after deployment what the resource utilization is going to look like. And so all we need to do here to execute this, or actually, before we do all that, let's go look at my variable file. So this is the build. This I should never have to go in and change. This is ready to go all the time for me. All I need to do is come in here to my Ansible variable file and specify all the information that I'm looking for here. So we can see there's my vCenter, there's my username and password, my data center, cluster, and data store. There's my bench and IC snapshot. We can see here setting it to 12 cores, 12 CPUs with 6 cores per socket, 32 gigs of RAM. Yes, a linked clone. I want 4 of these VMs. I want you to use this naming convention, and I want my folder to be under the deploy Ansible folder here, which you can see is empty. And so all we need to do is run Ansible playbook, and we reference my build file, my build YAML. And what we're going to see here, we come back over here, as this goes through, is we can already see a clone taking place and powering on that virtual machine. And if we go and look at this virtual machine and open up a console, we can already see it's booting up into Catalina OS. There we go. So Ansible's already done. It's telling me that everything is ready to go. And if we come back over here and look at the system, we can see the boot process still taking place. And we're going to see that it's going to grab an IP from my DHCP scope as soon as it finishes booting up here. And we were talking before, another things we can specify, we can change the network adapter if we want to. And if we look at the storage here, I told it to go to a local SSD drive, so we can see that it's referencing that. And if we look at the hard disk here, we can see that my 90 gig is showing that it's running on the local SSD. But we also still see down here in the related objects are sandbox iSCSI. So that is it referencing back to the read-only disk. And we can see now I have 10.250.0.80, and I can quickly start using this VM to do what I need to. And so that's building it up. Well, what about tearing it down, right? Because Ansible is ephemeral. So I've finished running my commands, everything, all the other playbooks I need to run. I want to tear it down. Well, we're going to go to this tear down file here, and we're going to see it's very similar at the beginning. We have our variable files in all the systems. And even into the task, we have, a similar VMware guest. But all we need to do here is specify the name of the VMs that we're trying to remove. Again, we're using my variable file to determine that. And I'm going to set the state to absent and force, which basically means I need you to make sure these VMs do not exist in this environment. And yes, make sure it's done completely. And all we do is say Ansible playbook and teardown .yaml, and we'll see that it goes through, finds those VMs based upon that name, and then we'll power them down and start deleting them. And just like that, I've had 4 Catalina OS VMs up and ready to execute commands, and now I've cleaned up my environment to be run again and executed again. All right, next we're going to look at Terraform. So Terraform is a little different. This is the stateful type of tool. In this case, we can run it on Mac OS, Linux, or Windows Server. We're going to be using that same Catalina VM that I was using before. We are going to be running the latest version of Terraform, 12.25. And in Terraform, we need to add a provider. They call it the vSphere provider to do the system. Now, right now, there is a bug in Terraform when it comes to the network configuration. VMware Tools is passing the IP information back. Terraform is not interpreting that correctly. So because of that, Terraform assumes that the build didn't work and failed in some process after a certain amount of time. So there is a flag that we can set in our configuration that tells it to not worry about the network, to just go on ahead and assume that everything was built out correctly, and we'll be good on that. We also have to specify a network adapter type in this case. They want to know what type of adapter we're going to be deploying. We'll cover that in a second, what those options are. We also have to specify the host with the data store when using local SSD. In Ansible, all we needed to do was specify what data store we're going to, and it would be able to logic out where it needs to go. In the case of Terraform, it needs a little more instruction. We have to specify the host as well as the data store if we're doing local SSD. If you're doing shared data stores, then DRS will handle a lot of that process for you, and you won't need to specify a particular host. VMware guest ID is another property that we're going to have to set in the system. We're going to cover how we identify those because they can be a little tricky to find. In the case of the actual structure, we're going to be creating a couple variable files, and then all the execution is going to be executing from a main file. And another last requirement in Terraform is that instead of specifying a snapshot name, their expectation is that you only have a single snapshot on the template. So if you have multiple snapshots on there, the process is going to fail with that particular image. So we're going to exit back out of there, and we're going to go back to our deploy server. And I have a folder here on Terraform, and we're going to look at those different tasks. So first things first is our variables file. So variables.tf. This basically just defines all the different variables that we're going to be using in this environment. So we can see here, very similar to Ansible at the beginning, our vCenter server, username and password. We are going to set the unverified SSL as well, our data center and cluster, the template folder. So they want to know where the template should be found out there. And then we get into the actual configuration. So VM count, the name prefixes, the data store and network, the VM host and folder I'm deploying to, CPUs, sockets, and RAM, VM name, guest ID, template name, and then finally, again, linked clone. So you can see we didn't actually define anything here. This just gives us the shell to be able to use those variables in the environment. Where we actually define those variables is under this terraform.tf vars file. And so if we go look at that, we can see here all those variables I defined. Here are the actual outputs for those systems. So we have one VM that I want to build using the Terraform or TerraTest name. We can see my template I'm still referencing, the CPUs and RAM. Here is that guest ID. So in the case of Catalina, Darwin 18_64 guest. And so a way to try and determine what that is if we come in here to our VM that we've built up, we can go to edit settings on that VM, under VM options, under here, the guest OS, we can see the Apple Mac OS 10.14. We can go out to VMware's website to go see what that guest OS version is to be able to type in that exact syntax that VMware wants, or Terraform wants for this value. And this is a required value in the Terraform deployment. You can see here my vCenter, the same username and password for access. We set my unverified SSL to true. My data center and folder we're going to be deploying to. There's my network for private 1. And here we're defining what I was talking about before, the data store and the host that we're going to be deploying to. So we need both of those options in our deployment to set the system. Finally, we're going to be deploying to the cluster 12C, and I do want this to be a linked clone. So we've defined all the variables I want, but where is the actual work being done? And that is actually done in what they call the main, or what I have here is the main TF file. So here we're defining some of the data around here, and we're using my variables to define that information. So the vSphere data center is going to be my variable.vSphere/data center. You can see here we're logging in with the provider vSphere with all that information. So again, we're just defining things up here, including where the template lives and template name, but it's actually down here under resource that we're going to be actually deploying the VM. So we can see the VM count is based upon my count here. The names are going to use that count and index up. We're going to use the resource pool based upon my cluster, my folder information, and my data store ID. The host is my host system ID there. Number of CPUs, memory. There's my guest ID set there. And then finally, we have that network flag that I was telling you about. wait for guest net timeout is set to -1, which basically says do not wait for the guest network. So normally this is about 2.5 to 3 minutes that it'll wait before failing. I'm saying I don't even need you to check on that. And then another static property we need to set in here is the network interface and the adapter type for that network. This is just a quirk of Terraform, and what they're referencing to is inside of your VM. If we go and look at the network adapter, we can see that there is actually an adapter type associated with it. So the E1000E has been a really old standard for a while. VMware moved over to VMXNet 3 a while back. VMXNet 3 is dependent on your VMware tools working in your environment. So if you just want to be safe and don't want to have to deal with worrying about any tools or systems like that, you can default to the E1000E as your network adapter type. We're adding on a 25 gig disk as well. So this is going to be our writable volume in the system. And then finally, we're telling it, hey, I want you to clone from my template, and I want it to be a linked clone. And that's a yes or no based upon what I set in my Terraform TF vars file. So we're in the directory where all these files live. You can see my TF vars, variables, and main TF are all into this Terra folder. And that's where we're at right now. And so to start this off, I'm going to run the command Terraform and then say init, which is the initialization, just to make sure everything is good before we do this. And that's how it determines that we are using a vSphere provider. If you don't have your provider installed, that initial step will make that provider available on your system. And then finally, all we have to do is say Terraform. We're going to say apply in this environment. And it's going to go scan this folder, and it's going to see all the files that I've defined out there, and it's going to give me the output to say, hey, this is what you want me to do. Are you sure this is all good? We can see all these variables and stuff set in the environment that's based upon what we set in the variable system. And so we're going to assume everything looks good here, and we're just going to say yes. And so now it's going to go out there, and already Terraform says it's done. We can see that a clone was completed and a power on happened in less than 2 seconds of this environment. And again, we go back and look, and we can see that the system is already booting back up. And we have our 25 gig hard drive. The variables we set in there were 12 CPU and 30 gigs of RAM. The private network is set. And again, because we deployed the local SSD, we still see the Sandbox AI SCSI shared storage on the system. Oops. All right, and so we've built up this system. We're ready to go, and it's just as easy to tear it down once we are done with this system. So Terraform, destroy, and there is a command called auto approve that you can tack on at the end of there, where I'm saying I don't need you to validate with me. I just want you to go on ahead and clear that out. And so there we go. It's going to initiate guest OS shutdown, try and tear it down, and remove that VM. All right. So that is, there it goes. Well, that's the Terraform side of things. So hopefully, I know we went kind of quick. There's a lot of material to cover there. A lot of the examples that we just used here are going to be available as handouts as well for you to go back and reference. Now we're ready for some Q&A.
Hey, Max, I have a couple of questions that have come through the questions pane. Just a reminder, everyone can go ahead and put those in there. So the first one is, how large does my environment need to be to do this?
So your environments can be as small as a single host and a single data store in a vCenter environment to be able to execute this. You will need a vCenter to execute the commands against. I don't believe they can work against standalone ESXi hosts. And you will need it to be licensed as well. Free ESXi does not have API calls, but bare minimum is just a single host, single data store, and then you can go forward.
Awesome. So our next question is there a pre-built template I can use?
So MacStadium does not provide templates of systems. However, we do provide an ISO data store. that has ISOs for all the Mac OS installations. So you should be able to build out your own versions and templates of these systems based off that ISO just to get it exactly where you want it to be. And if you don't have that, you can open a support ticket with the MacStadium and we'll get that for you.
Great, and it looks like that this might be our last question. So what version of ESXi does this work with?
So we generally would recommend running at least 6.7 general release as the bare minimum. I believe the linked clone commands date back as far as 6.0, but most of the automation tools and everything out there will expect at least 6.7 as the bare minimum. Yeah, and as far as we know, there's not going to be any major changes, and these tools will typically keep in line and up to date as VMware releases new versions.
Awesome. So I think that's our last question. So I want to thank you all for joining us today. The webinar will be available on our YouTube page in a few days. So if you'd like to subscribe and keep up to date, that would be great. Thanks again for joining us, and I hope you guys have a great weekend.
Thanks, everybody.